and I prepared the presentation for tonight about digital voice. I'm going to explain a bit about how digital voice works, some characteristics, and at the end of the presentation, some products I made and their possibilities. Okay, it works. And let me check this one. Okay, that works as well. So very good.
I will break in here for just a second, Gus, to tell people it is now roughly 3:00 a.m. in his time. He got up special for this presentation, and it is not Thursday for him, it's Friday. So,
it's Friday, exactly.
So go ahead, Gus.
Day before Sinterklaas.
Yeah. You might have to explain that to a few of these folks.
Yeah, exactly. 3:00 in the morning. I'm out of bed now for, let's say, 3/4 of an hour. My wife was a bit suspicious, but no problem. Okay, I'm going to talk about tonight what is digital voice and how is digital voice implemented in a radio. So I show you a small, simple diagram where digital voice come in as compared with a standard analog radio. Some characteristics of DMR, D-Star and Fusion, that are the most common modes. Going to talk a bit about repeaters and hotspots, and what happened 7 years on the road. 7 years ago, I started, but I show you a bit of what I did last 7 years in terms of what kind of products, prototype software I made. It's a walk through, what I did. Okay, what is digital voice? It's actually digital data modulation of a RF carrier. So the transmission is still analog, but I come to that later when I take every mode apart. The voice is digitized audio. The digital voice is compressed by a vocoder. In fact, you put the PCM on 128 kilobits in, and the vocoder, the MV3000, brings it down to 3000, approximately 3600. So that's quite compression. Voice and data in some modes are provided with forward error correction. That means that due to fading or noise, the signal can be corrupted, and there is a forward error correction added to data and to voice, and for some modes in data, to correct the data on the receiver side. The voice and data are sent serially in packets of uniform length. So that means, but I show that later on. And header data, so every transmission has a header that includes ID and routing info. All you need to make a digital voice transmission. The TX implementation, in fact, what you see on the top is a standard analog radio, an FM radio. The lower part of the schedule is the addition when you make it digital. So we cut the line from the signal conditioning to the FM modulator. We cut the line, feed the analog signal in an analog to digital converter. Then you have speech samples. I spoke already about 16 bits, 8,000 kilo samples per second. And then you come at the rate of 128 kilobits a second, which is standard pulse code modulation, PCM. The speech sample goes into a vocoder. That's what we use, the MB3000. And you see that the data stream that is compressed is only 3.6 kilobits. I mean, we still have to transmit in a 6.25 or 12.5 kilohertz bandwidth. So we never can get the 128 kilobits a second in that small bandwidth. So that's why the voice is compressed. Then the data coming from the MB goes into a framer, and that framer makes packets of a uniform length, and it can add a user ID, destination, etc. So that every packet that is sent can have the information of the sender. Then it goes into a modulation formatter, a pulse shaper, so it becomes a signal, GMSK or 4FSK, but on the signals I come back later. Then it goes back into the FM modulator and it is transmitted as a analog RF signal. So in fact, this is the addition to an analog radio to make it digital. Now, in fact, the RX side is the same, but the other way around. It's filtered. The only difference from the TX side is that you have a clock and a data regenerator. So that makes a synchronization system on the received data. A deframer, here we have the vocoder again. It makes from 128 kilobits from the 3.6, and it goes back into the audio amplifier, and it's standard analog voice again. The characteristics of the, let's say, the three different modes, the three major modes most used, DMR, D-Star and Fusion. Tell a bit about the RF spectrum, the repeater connectivity, the data structure, and signal quality compared with analog. So, RF spectrum. D-Star, it's 6.25 kilohertz bandwidth. DMR as well. And the difference between D-Star Fusion and DMR is that one has FDMA and DMR has TDMA. And TDMA, time division multiple access, that means that in one RF stream you can have two channels. So that means that two people can speak on one frequency at the same time. So in D-Star and Fusion, it's like in analog. Speaker one has one channel. Let me see, I can zoom into that. Speaker one has one channel with the according bandwidth. Speaker two has the second one. With TDMA, you have on one channel, you can have two speakers. So that means that the channel is dedicated for 20 milliseconds, for example, to channel one, and 20 milliseconds to channel 2. The trick is that you put the double speed data in one time slot. The receiver puts it in a buffer and spread it out over the 40 milliseconds. So, and after the 40 milliseconds, the second frame of the first time slot is coming in. So that's actually the big difference between D-Star Fusion, which uses FDMA, and DMR uses TDMA. So it's also when you have a repeater, you can have a local channel and a regional channel on one frequency, on one repeater, on one piece of hardware. So repeater connectivity between the three most used modes. The digital voice modes are commonly used on repeaters or networks. At least here in the Netherlands, you don't see a lot of people talking direct to each other, talk locally. So talk direct to each other as an analog radio without repeater. So very, very strange, but I don't know how it is in US, but here in, I can say North Europe, it's common that you use your digital radio in combination with a hotspot or a repeater. Maybe because, yeah, I can say every repeater is connected to the network. Maybe that's a reason, but point to point, locally, it's not used a lot, but it's of course still possible with D-Star DMR Fusion. A link to another repeater, that means that you can connect your hotspot or repeater. You can connect a repeater to repeater or hotspot to repeater without having a network, a master or controller whatsoever behind. With the DMR and Fusion, that's not possible. The multi-repeater connection, when you connect to a network, on D-Star you connect, it's called reflectors. On DMR it are talk groups, and on Fusion it are wires X rooms. The selection or connection method is a UR entry. In D-Star it means that you give a code, a command. You press PTT once that command is sent to the reflector, and or to the repeater, sorry, and that repeater connects to a different reflector. So when you are connected, you go back to a command which is CQ, and that that means you can talk now. So you have a command to connect or change a reflector or network. For DMR, it's a channel dial. So we see that later. DMR is different from D-Star. Every voice packet has routing info. And that info says to which talk group you are talking to. So you can change that on fly. You don't have to send a command first. Your destination is integrated in the data you send. And WireX rooms is a room name. It's a system like D-Star. So you connect to a room and then you're going to a speak mode. Route to another ham. So that means that normally when you speak through a repeater to a network, everyone who is listening into that repeater or network or the channel can hear you. And with D-Star and DMR, it is possible to have a sort of a private call, so that you connect direct to the endpoint of your ham friend. With Fusion, that's not possible. Echo test, it's a parrot in the network, so that's possible with all 3 modes. And the request link status, that means can I check, can I give command that the network tells me to where I'm connected to, and that's only possible with D-Star. The next one is the data structure. I don't go into very deep detail, but just to have an idea, when you press your PTT, what happens? And how does the network and the other stations that listening in knows who are you, and where is the voice and the data put in the stream. So every transmission starts with a radio header. It has some signaling information. First, a bit pattern and a frame sync. So the receiver side must have the ability or the possibility to see the start of a transmission, of a pass. Then you have some flags whether your transmission which comes in directly or via a repeater. The destination call sign, the departure call sign, all information that tells the system where your stream has to go to. Your own call sign, and again your own call sign, but that is where to go. And when the radio header, which contains ID and routing information, then comes the data in. In case of D-Star, you have a voice frame of 72 bits, and you have a data frame, voice data frame, and that repeats as long as the transmission takes. In the voice data, you have the 3600 bits a second of compressed data, and it's between every voice frame is a small data frame of 24 bits. The data frame can contain data of, for example, GPS information. It can hold a short message. It can hold all kinds of data that is sent on top of the stream when you are speaking. And if you release the mic, there is here a sort of end of transmission frame. So D-Star always start with the header and then voice data, as long as the transmission takes. For DMR, it's a bit different. You have a data frame, data frame. The red slots is a sort of silence, because I told before that the DMR is a TDMA system. So the radio sends data and listens, sends data and listens. Every 30 milliseconds it sends a packet and it listens. The sync, the data sync is in the middle of the packet, compared with D-Star, where you have it up front. The frame sync is up front, and in DMR you have a sync in the middle. Every packet you have the sync. Why is the sync in the middle? Because the receiver and transmitter switches every 30 milliseconds from TX to RX. And you cannot allow a very long sync in the front, but you need to keep this time as short as possible. So that's why they have put the sync in the middle, because then the receiver side is synced to the data, and the sync is already synced to the data. It's better to read for the RX side. In this data is in fact almost the same as in the D-Star. It's ID and routing information. It tells the system who you are and where you want to speak to. And then voice frames with a voice sync in the middle that can have some data in the same way as D-Star has. It can send the GPS information, small text, etc. So where you have a sync up front in D-Star, you have it in DMR in every voice packet. Fusion is yeah, it's more like D-Star. It has a frame sync and a frame information, and this frame information is more or less the same as the radio header in D-Star. It sends voice. It sends data, and it sends voice, data, voice. Because the speed of Fusion is double, the data speed from Fusion is double from D-Star, it sends, let's say, 144 bits instead of the 72. The data structure. Then the signal quality of digital voice compared with analog radio. If you're moving away from the TX side, and that can be a repeater or a other radio station, then in analog, the system or the signal becomes noisy. How further you are away from your other station, it becomes noisy. With digital, because of the error correction in the analog part of the digital radio, of course there becomes noise as well. But this part here, the forward error correction takes care for this part, so that when you have dropouts, when you have noise in the signal and some bits get lost, the digital part reconstruct or correct the received data. But at a certain point of time, it's impossible. If the error bits are more than the error correction can correct, then your quality of the voice drops down very, very quickly. So in fact, what you see is that a digital signal remains unnoisy or continues for a longer time. There's always a discussion whether the readability is better, but still this is how the signal behaves. That small introduction on the different modes, the technique, the characteristics behind the different modes. And now a bit, I told it briefly before, I'm doing 7 years digital voice developments. Start with some kits which I show you in the next slides. And yeah, learned a lot. I started 7 years ago, of course, with my knowledge of electronics, but I knew a bit about forward error correction because I used to work for Philips from 1978 to 88, and I worked in the development of the compact disc. So I had some, I learned a bit about error correction, because in fact in reading a compact disc is the same as receiving RF data and decode it. So in fact what I made and learned about the different modes, the protocols, one is simpler as the other. I mean, DMR is much more complicated than D-Star is, also the error correction techniques behind. It took me 7 years to come where I am now, and it all started in May 2013. There was a hotspot made by Mr. Satoshi. It's a Japanese ham radio, and an ham radio amateur, and he was, so as far as I know, he was one of the people that did the D-Star spec. He made a PIC-based, a PIC microcontroller, that's this one, a PIC-based DV node. A DV node is in fact a hotspot, but it's only the hardware. It's more a modem, and you have to connect a 9K6 capable radio to it, and then you have your own hotspot or repeater. In fact, the difference between a hotspot and a repeater is that a hotspot is a simplex repeater, and normally you send your signal to a repeater, and the repeater sends your signal to the network, and it retransmits the received signal. Hotspot is not doing that. The hotspot receives a signal, sends it to the network, and only transmit the data received from the network. So this was the first GMSK modem for D-Star I made. It was, I had no intentions to produce in quantities. It was just to learn about the protocol and how digital modes work. In August, I moved, I kept the same modem hardware, but I moved to an Arduino because the Arduino became, and I think was already popular at the time. And I thought maybe to make the project available for other people, it's better to go to an Arduino, because the hardware is very easy to get and is very affordable. And there are no such nice boards to play with based on a PIC than Arduino has. So I moved in August from the PIC-based to Arduino-based. You see for the people that know, an Arduino Mega underneath this one. And later on, I moved that one to a Arduino Uno, an DVMEGA 328 based board. These modules are at that time only based for D-Star and needs a separate radio. So when you want to have your hotspot at home, then you have to offer a spare radio with a 9K6 data possibility. So almost every radio has the 6/9 pole mini DIN, and they can do the job. I thought there must be a way to do it with a small chip. At that time, the red dongle made by Robin Cutshaw was already available, but that was not, yeah, open. It was a complete product, and my intention to that time was to make kids boards where you can play with. So I started some work with the ADF 7021, which is actually the basis for all, yeah, for every hotspot now, whether it is a zoom spot, an MMDVM, whether it is an open spot, or call them, and they have the ADF 7021 chip in. In January 2040, I moved from a single band hotspot to a dual band hotspot, VHM or VHF or UHF, still based on a Arduino module. That means that the host software, that is the software that lets you connect to a network, runs at a PC, a Linux or Windows PC at the time. And then the Raspberry came in, and this board on top is the DVMEGA as it is still today. And the funny thing is that I was playing with this kinds of board and had a bit the feeling that yeah, this board could help people making a hotspot at home. And I thought I have to make one which fits on top of a Raspberry Pi. And that's this one. So actually the DVMEGA found is in the way it is today, is origin at on top of a Raspberry Pi. From there, a GMSK modem shield to make T-star repeaters. Then the MB3000 came in. This is the vocoder board. I had the intention still at that time to make boards where people play with, but we shall see that in a few slides that time changes and that people prefer to have complete products. But it's still available, GMSK modem shield, MB3000. To do, you see the analog to digital converter here and the MB. So this board can be plugged on a Arduino Mega, and you can do your own vocoder experiments. The dual band module for the Raspberry Pi. And actually in December 2015, I had the first ID for the DVMEGA Cast. It was only a prototype. There was no rotary encoder in. It was a standard potentiometer with a speaker on top and a dial. Yeah, in a few slides you see what the cast looks like today. But this was the first mock-up of the DVMEGA Cast. June 2017, then say, hey, I missed 2 years, but in 2015 to 2017, the hotspots became very, very popular. DMR came in, Fusion came in, and I spent 2 years to visit all kinds of exhibitions like Dayton. I went, let me think, 5 times to Dayton, to Hemcation in Florida. I went to Tokyo, Ham Fair, to Friedrichshafen. So I spent 2 years to visiting all kinds of exhibitions and of course do the production, because again that time hotspots became hot. 2017, the DV stick. The DV stick is a USB MB vocoder that you can use with Blue DV to have an IP radio without radio. So you have a piece of software, you plug the stick into your PC, and you can use the different networks. So you don't have any RF side on your IP transceiver, but you can talk through all the available networks. And it's good to know that the other side do not notice do not notice that you are an IP user, because everything is, the protocol is 100% to the RF protocol. May 2018, a detail is the DV Stick 33. It's the 3-channel variant of the DV Stick 30. Then in 19, the cast came in. It is an IP radio. It has, besides the Wi-Fi, no RF in. You connect your radio. Allow me to call it a radio. It's an IP terminal via LAN cable. Or a Wi-Fi to the internet. So that gives you the ability to connect to networks. It has the protocol DMR, D-Star and Fusion in. So you can talk to the networks as you use them via a repeater. Also, the method of linking, changing channels, reflectors is the same. So you use it, it behaves like a radio, but you're going through IP. It's used by many people mobile there, where they don't have a repeater or whatsoever coverage. They put a Wi-Fi dongle in and they link it to the phone. Switch your phone in hotspot mode, link it to the phone, and used in RVs, in trucks, in mobiles, to talk to their colleagues from areas where no coverage is. It needs host software. It needs software to connect to a network. At this moment, there is a NanoPi, which is a very small Raspberry Pi. Let me see if I have one. No, I don't have one here. It's a Raspberry Pi, approximately 4 by 4 centimeter, and the host is G4 KLX software. It's the DVM host. In fact, many people call it the Pi Star, but in my opinion, that's wrong. Pi Star is the image, and the software that's used is DVM host, made by Jonathan G4 KLX. It has a 2.4 touchscreen for setup and control, so you can you don't have to pre-program the radio. You can select a talk group on the fly. You press the number 204. Actually, that's the label that shows you to which talk group the radio is programmed. You press that one, and you can select another talk group, a private call. That's the system I mentioned before. So you can check the private call box, enter the ID of that the one who you want to talk to, and you have a direct connection to him. It supports a standard MH48 mic with keypad, so the key buttons are implemented. So You don't have to use the touchscreen. I know it's always a compromise between size of the radio and size of the screen. It's very simple. You cannot put a 4-inch touchscreen in a 2-inch high radio. So you can use the buttons at the keypad at the mic to connect and control the most important functions of the radio. The rotary encoder for volume and multi-functionality to do menus, to store preset volume, etc. Supports D-Star, DMR and C4 FM. The DVSI MB3000, the original one, is integrated. Why I do mention original, because I think they took them from the market, but there were some copy fake. Actually, it were not copies. It were illegal binaries of original chips. There is a web-based upgrade utility. So when there is new firmware, you can go to the website, you enter your serial number, your service code. The two make your radio unique. There is a software version compiled on the fly, and you can download it immediately. You go via a web-based download utility into the radio, and the update is done. It has two options for additional modules. You can put a radio, an hotspot module, like I showed on top of the Raspberry, inside the radio. So you can use the Cast as a hotspot as well. And you can put a DV dongle stick, a DV stick 30 in. So, and that makes an MB server. And yeah, the fact MB server, I come back to that in the next slide. Low power consumption, 12 volt DC. It has a standard 2.1 mil barrel, so barrel connector. It's the 2.1 round DC connector, almost all. Yeah, it's a very common DC connector. There is a light in the speaker. It's blue, green, and red. So it's red when the radio is idle. It's green when it receives, when it opens, in fact, the squelch, and it's red when it transmits. From a certain version, you can dim the power of the LED, because in some dark shacks, it was a quite bright LED. There's an external speaker connection, high performance, at least we think it's a high performance 3-watt speaker, extra USB connection available for future use at the backside. And it's all in a, yeah, quite rough metal powder coated housing. It comes in this box. And at this moment, the software for the radio is still under development. We try to bring 2-3 updates a year, and at this moment we are working on preset lists and some requests people made for easy use of the radio. So the firmware is still not under development, but is still extending and improving. But the full functionality for D-Star, DMR and C4FM is in. Then the next one, and that's totally new product, sorry. It's DVMEGA Globetrotter. It's a Wi-Fi MB server. What is an MB server? You saw it in previous slides several times showing up the MB3000. For every digital mode, whether it is D-Star, DMR, Fusion, P25, NXDN, whatsoever, you need an MB vocoder. The MB vocoder, again, 128 kilobits PCM are going in, 3600 bits a second are coming out. MB data, and that is the data used on RF and the data that is sent through the networks to other repeaters or reflectors or hotspots. And David, PA7 LIM, made a piece of software that can use an MB so that you have an app on your mobile phone and connect to an MB, because that is a piece of hardware where no software is available. There are some binaries, but we cannot use them for commercial purposes, because there are DVSI patents and the binaries are, I won't say illegal copies, but when you're going to sell the products with that binary in, then you're becoming conflict with their patents and their rights, how you call it, author rights. So this module has Wi-Fi on board and the MB3000. You connect it to your Wi-Fi at home. Install the BlueDV app on your phone, and you can use your mobile phone as a D-Star, DMR or Fusion radio. It's very handy when you have to travel, again, when there is no repeater or RF coverage, when you stay, for example, in a hotel, make business trips. You don't want to carry all your ham equipment with you, but you still want to stay in contact with your local group of hams. You can open the BlueDV app, and the BlueDV app connects to the MB server at your home, in this case a Globetrotter. You can connect via Wi-Fi, and you can use it as a USB MB dongle. In fact, it gives not that much advantage for this product, but it was easy to implement. It's powered from a micro USB phone charger. It only draws 150 milliamp with the Wi-Fi on, so yeah, every phone charger can handle the current. A 1-inch OLED screen for the status and settings, and an easy to use setup via buttons. Today, most products have a web-based configuration panel, whether you have let's say a Google Chromecast or a Pi-Star whatsoever, but it seems that still many people have issues with finding the IP address, etc., and getting the Wi-Fi up and so on. So I decided to, with this product, at least because it's only you have to set up once, and then if you don't switch the network, the Wi-Fi network, it stays there forever. I choose to do the setup by buttons with using the display and the buttons instead of having a web interface in. The new thing is that it has a automatic firmware update service. So every time you start this Globetrotter, it checks whether the firmware on my server is the same as the firmware loaded in your product. If not, it tells you before it starts through, hey, there is a new firmware version do you want to upload it? The only thing you have to do is press OK or not OK. You don't have to download firmware, you don't have to search for upload tools whatsoever. Once you connect your Wi-Fi, every time you press reset or you power the unit up, it checks whether the product is at the latest firmware version. If not, it gives you the possibility with one button to upload new firmware. Support for BlueDV. It has again the original DVSI MB3000. I spoke about the power supply and the current draw, and it's a solid ABS housing. To give you an impression of the size, it's like 8 centimeters wide and 5-6 centimeters high. It's 2 centimeters thick, so it has the size of let's say a pager. I've made 5 samples now. We have them at some people that have the unit under test, and I think the main production sorry, is ready by the 2nd or the 3rd week in January. So there's a new product coming, DVMEGA Globetrotter. And that's the last slide of the presentation. I always end with, not with this was a presentation of thank you, but what do you like us to do next year in terms of improvements of current firmware, IDs for new functions, or maybe new products. Thank you for listening and watching.
All right. Thank you very much. Like I said before, if you go down the bottom of your participants, then you can raise your hand for questions, or you can put questions in the chat. There's already some questions in the chat. Barry, you want to cast those?
Sure. Someone wanted to know if they could plug into an existing radio with a 9K6 mini DIN port and do DMR/D to star, etc. Are there any such devices for sale?
To plug in your standard radio and with the what you mean actually, is there a sort of front end that you can use your standard 9K6 radio as a D-Star or DMR radio?
I'm just reading what was posted by Mooner K6AQ from California. Maybe he can put his hand up and ask the question. There is another one. What about the DV Stick 30 and the DV multicast?
In the DV Cast, yeah. So there is but that's the first question. Let's say the answer on the first question. There is a experimental piece of firmware. Then you need the MB3000 module and a Arduino Mega, and then you have a D-Star front end. So then you can turn your standard analog radio into a D-Star radio. Protocol is fully compatible with standard D-Star radios, but for DMR and now Fusion, it could be possible, because that is FDMA 9K6, but for DMR it's sorry, it's very hard, because DMR radio switches I think 15-16 times a second from RX to TX. So no, but for D-Star there is a experimental module. Then what is the DV Stick 30 doing in the DVMEGA Cast? That was the second question, I believe.
Yes.
Yeah?
Yes.
So then that turns the Cast into a MB server. In fact, the same functionality as the Globetrotter, but then you can plug the USB dongle in your radio. And when you start up the DVMEGA Cast, it detects the DV30 stick and it switches the MB server on. So when you switch off your cast, at least you think you switched off, but it becomes in a sort of standby mode, the MB server keeps running. So you can, in fact, what you can do is in the middle of a conversation, you can switch off your cast and you can take over the conversation with the Blue DV app on your phone and move away from your cast, even move away from your house. So it's the MB server functionality in your cast. Why? Yeah, because there is enough CPU resources available. There is a USB port inside and on the back of the unit available. And it's a option. It's a quite handy option when you want to use the Blue DV app. That's it.
Okay. That's basically all the questions. There were a bunch of thank yous for the explanations. So a lot of people learned a lot from the explanations of the differences between the different modes.
Yeah, it's always hard to know the level of knowledge of the people are watching or listening, and I don't try to go too deep into detail, but yeah, show the difference. And if people hear, yeah, what's the difference between D-Star and DMR?
Right. Okay, another question. Is there any potential of using the DVMEGA Cast, Megacast, to create a fusion room?
To create a fusion?
Yeah.
Room.
To
Fusion
create
room.
a fusion room?
Yeah.
No. No.
Okay. Imagine you would need fusion to do that.
To create the fusion room, yeah, you have what I know in detail of fusion, that you have again several systems. You have the YSF, the SCS, and you have the Yaesu fusion rooms, the Wires X. The FCS, which is the German reflector software, the YSF, which is the reflector software by Jonathan, works different from the Wires X. Wires X has also a possibility to do analog input. That's why it's called fusion. So people which are coming in via fusion analog can talk with people talking digital. And to create, I think the question is to create a real fusion room on the Wires X. And for that one, and that's also why we have FCS and YSF, for that one, you need a piece of Yaesu hardware to be able to create a room. So, yeah, I don't know. I don't think it's possible right now. What is possible is to create a YSF or FCS room, but there are already so many. But that must be possible, because the FCS or YSF room reflector software is written in Linux and can run on a Raspberry. So yes, that is possible, but I think they mean Wires X rooms, and that's not possible as far as I know.
Okay. I'm good, Dan.
Okay, sounds good. I happen to have, I fell in love with this thing when he first came out with the DVMEGA Cast, and I bought, not one, I actually have 3 of them right now. And one I leave at the cabin, and although I have it down here for the winter, and one I take on when I travel with for the clubs and go out to Hamfest and such. It's a handy thing. Does a hotspot do it? Yes, the hotspot does well. I have a whole slew of hotspots. I can take a handheld with me, and I can take a hotspot, have it on my belt or whatever, tailor it to my telephone, and I can be walking down the street or walking through a Hamfest and have complete communications back home or anywhere I want to go. It's a different way of thinking. It's still radio. It's people say if you use the internet, it's not radio, but almost everything to do with the radios anymore is tied to the internet in some fashion. Of course, if the internet goes away, it depends on what your device does and what's left. It's operational.
Yep.
I don't see any more questions.
Yeah, and I think it's important to mention that some people compare an IP radio with Echolink, but in fact the only common between those two is the internet. With an IP radio, with Blue DV app or whatsoever, you are fully compatible with the radio amateur protocols with D-Star, DMR and Fusion, and you are not with Echolink. So again, if you are using an IP device, the other end will not notice that you are using it. Not that they not may know, but it's fully compatible. That's what I like to add to that.
Yes, very transparent, very transparent. Gosh, I'm trying to, I'm
thinking for disaster, something like this would be good for GoKit because people have different kinds of handhelds. And this way, the Fusion radios and the D-Star radios and everyone can all talk to each other from your command center. You have it in your GoKit, and you wouldn't have to worry about it.
One of the things that Gus was working on earlier on, and he made up a special software patch for me that worked very well, but he got off to some other projects, and that is at some point that when you have the hotspot embedded in the DVMEGA Cast, you put the accessory in there, it will now work with, once the software change, it will now work on both the hotspot and the IP radio. So the person can sit with the IP radio can set their being on D-Star or whatever he or she wants to be on, handling whatever traffic they have to be, and other people could be using the same deal through the hotspot using their handhelds on a different mode. And of course, if you've got the DVMEGA 30 stick in there, you have another option, be doing that with your cell phone. So it gives one box that in a disaster situation performs multiple tasks. And I can see right now, they're very reliable boxes. They're built very well. Okay, I don't see any more hands. I don't see any more.
There is one more in the chat room now.
Yep.
Okay.
Will the DVMEGA Cast connect to a Fusion Wires X room? I know it connects to YSF and FCS, but does it connect to Wires X rooms?
No. I spoke to the director of Yaesu 2 years ago at the Ham Fair in Tokyo. And for example, for D-Star, ICOM, in fact, the protocol is not designed by ICOM, but it's made by the ARL, and it's adopted by ICOM. And that's open, fully open. Everyone can do with that whatever you want. Yaesu do not want to open the protocol. So until now, you need to buy a, is it an HRI 100, 200 box? And that allows you to create or connect to a room. So no, it's not possible. It connects to FCS, YSF, and the new. I'm reading the next question. So no, it's not possible, and we still try to get it open, but I don't know why. In my opinion, when Jesu opens the protocol, people can play with it. It becomes more popular than it is now. I understand that Fusion is quite popular in US, but for example, in the Netherlands, Belgium, Germany, it's below average. So, but okay.
Someone wants to know what your opinion is of the 7-inch next-gen screen built by Heath. He has one. Jim has one, and he attached and he loves it.
I saw that, of course. I followed that project, of course, and it looks great. It's easier accessible than the 2.4 screen, and I think it's a great project. He is also getting full support in a way of the source files for the next gen, etc. Some people say, hey, can you increase the size of the screen in the cast? Yes, I can, but then the cast becomes bigger. I told it half an hour ago. It's a compromise between having a reasonable screen and a reasonable size of the cast. But I think it's a great project, and it helps a lot of people with a larger screen. Yep.
Okay.
The nice thing about that screen also is it could be programmed, so it's full color and all kinds of. Some of the guys have come some really creative backgrounds and such on that screen. So again, it's an opportunity for amateur radio to play and grow and take one idea and make it better.
Yep.
I'll probably think of 1,000 things afterwards, but right now I am running out of thoughts myself. Oh, do you now have I saw something. Do you now have the DVMEGA in cast in kit form?
What do you mean by kit?
I just saw something on it being in kit form, and I didn't think you sold it as a kit.
Let me see. Is my slides, my desktop still shared?
Okay. No, your desktop is not shared right now.
Okay, no. Yeah, we can go through very quickly. Let me see. This one. No, do you mean this one or?
No, I might have been on your flyer.
Okay. Yeah, I don't know. Yeah, no, there is no real kit. There is of course, the DVMEGA module, which you can plug onto a BlueStack or a Raspberry. No, but there are no real kits. The only thing that may come, where I'm working on the sideline, is no. This one, and that's a small hotspot with based on a Nano Pi, the same as used in the cast, with a radio board on top. So this is a complete. Oh, here in my white T-shirt, that's better. This is a full standalone hotspot based on Pi-Star MMDVM host. But no, there is no real kit. If you mean by kit a complete hotspot, then GigaParts sell those. I sell the radio modules to GigaParts, and they have made a box and they put together with a Raspberry Pi and sell it as a complete built radio hotspot.
Okay, a couple more questions have come up here. Barry?
Okay.
Oh, yeah.
I think this, Dan might have been talking about the DVMEGA dual band VHF UHF with Raspberry Pi 3 assembled kit. There's the word kit in it. So, but that's all fully assembled. The next question is, are there plans to update software to use the cast and the internal DVMEGA board at the same time?
Yeah. First, the previous question, GigaParts has fully assembled DVMEGA dual band kits with Raspberry Pi. Yes, there is experimental host software then has that, so that the cast and the internal DVMEGA board can run at the same time. The challenge is because the cast uses the MMDVM host software and the board uses that to start 2 instances on the NanoPi. And yeah, we are working at the site on that to make it available. What we did in the latest release, by the way, is we make the switch over from cast to hotspot. You can do that from the touchscreen. You don't have to go into the web-based configuration panel to switch over. You can do it via the screen. So it's already much easier than it was before. Yes, there will come a version where we can run them both together, but at this moment we gave the priority to the preset list because many people ask for that. So.
Okay. Next question is from Rob in Washington. We are looking into using MMDVM hotspots for our Go kits, but ran into issues when trying to connect to Wi-Fi with captive ports. Is there any plan for Pi-Star to have a mechanism for connecting to captive Wi-Fi ports?
I don't know. I don't know. Andy, MPS, he lives in UK. He is doing the Pi-Star, I mean the captive or the Wi-Fi port part. That's a real Pi-Star thing. It's MMDVM is the application, and that's a real Pi-Star thing. I know there are some challenges with Wi-Fi and Pi-Star, but I don't know the status. What I know, and I can add to this, I'm also doing a own host so that we can run the cast, but that will be somewhere Q2 next year before that's available. We can run our, my own host software, and I try to move away, or at least have the settings based on real touchscreen buttons. Or try to move away, but have it as an option, a web-based configuration, because one or the other reason many people facing issues with, whether it is connecting to Wi-Fi, finding the correct IP address. I have conversation with people that run 2 hotspots and try to do a setting and they end up in changing settings of their hotspot while they think they are doing the radio or the cast. Yeah, so my host and the Globetrotter is there the first example of will have a real settings on the equipment itself. So again, I try to move away from the web-based settings, and that in my case, because in the beginning I had a web-based portal on the Globetrotter to connect it to Wi-Fi, and it's crazy. It connects, it disconnects, it starts the Wi-Fi portal when it's not needed. It gives more problems than it helps you with an easy setup. So that's why I moved to real buttons, real display, and I will do that in the host software for the cast I am doing as well. And I don't say there will be no web portal available, but the base settings will be done by hardware.
Okay.
And that will then have, when I have the host firmware made by myself, I implement the same firmware update system as in the Globetrotter, because it's not only making a over-the-air a firmware update possibility, there is also a server side that has to handle the request to communicate with the database, so that you get the right I hear some strange sounds here on the back, so that it was some noise, and it's 4:20 in the morning now, so I don't expect that kind of noises here. But I'm going to make the same firmware update system then in the own host part for the cast. Yeah.
Okay. Are there anything else out there? I can tell you right now what I've done with mine. When I go to Hamfest and go to clubs and such, I have one I take there, and I can put a Velcro battery on top of it, but there's plenty of room to Velcro a battery underneath the lid too, so it can be internal. And that thing runs very well that way. And then of course I tailor it to my telephone when I'm in a meeting or whatever, and I can show it off. But, it makes for a very nice Go package. It gives you all 3 modes, actually more modes than that if you get into it. It's a very, and for the price, it's a cheap way of going. It does well.
Yeah, of course, yeah. Yeah, there is enough space. I think, yeah, I look to the right because I have a open, this is my developed model. And actually 50% is fresh air.
Yes, it is. There's lots of room in there for like your battery packs or whatever. Anyway, it makes for a nice, handy, compact device that does multiple modes and does multiple tasks for you.
12.4 megabyte an hour when listening or talking. Answer to the last question.
Great, thank you.
12.4 megabytes.
How much data does it take when tethered to the phone?
Yeah, 12.4 megabyte an hour. Because it doesn't matter whether you talk or listen. The amount of data is in a few bits the same.
Okay, great.
I know that Verizon and a lot of others, for the older people out there, if you're over 55, you can get on a plan that has a data thing for free. Actually saves you money on the cell phone too. So I went on that. I didn't even know about it. They don't really advertise it. Somebody told me about it. And that it's kind of nice. Anytime I want, I've got the internet available to me from my cell phone, and the data is free to me then.
Yep. Yeah, and we have here yeah, before we had roaming. Yeah? So when I move with my car, I live, let's say, 15 kilometers from Belgium. And when I cross the Belgian border, I had to pay for roaming. So when I'm in the Netherlands, my data is free. And when I'm in Belgium, I paid before like $25 per MB. So that's quite expensive. Now we have a roaming throughout North Europe. So that means you pay everywhere the same. I have a SIM card with, I believe, 7 gigs of data for €12, which is like $14. So, and if you calculate how many data that is, you can listen 24 hours a day, 31 days a month. So you can't come through your data. So.
Okay, well, I'm trying to say there's no more. Are there any comments? You do have a Facebook support page where a lot of stuff is talked about, do you not?
Yeah.
Maybe I can put that, get that. And
yeah. I don't know, but if you search on DVMEGA Cast users, there are 2 Facebook groups on the cast, and there is a Facebook group DVMEGA Cast Radio, and there is a group DVMEGA Cast users. There is a company, a one-man company in UK, and that calls himself DVMEGA UK. Years ago, he sold DVMEGA modules, and he refuses to change his name. And I absolutely don't have anything to do with that company. And the DVMEGA Cast Radio group is owned by him, and the DVMEGA Cast user group is owned by me. So if you want to get answers to questions, please go to the DVMEGA Cast user group.
Okay, I'm going to put that in, whoops, as soon as I think I have it here. And I'm going to put the URL into the user group for that.
Yeah.
Okay. I think that will take the folks to your Facebook page where there's a ton of information and lots of conversations on these things.
Mm. And yeah, they also can visit www.dvmega.nl and check the cast tab, and there is a user manual in English, and they can see what the cast is doing, can do, and how you control the unit.
Okay, well, it's getting kind of late, and I think we've exhausted most of our stuff here. And for you, you get to go back to bed.
I go back to bed. I think I make it to 8 o'clock this morning, and then I have to move to Belgium again today. I have some customers in the center of Belgium that I have to visit today. Unless COVID, yeah, I have to go. It's has to do with the sauna equipment, and they have an issue installing, and yeah. I have to go with my face mask and so on, prepared and protected.
Oh
Yeah.
boy, there'll be a field service there. Well, thank you, Gus, very much. I see people in the chat that's also thanking you. It's been a good
Yeah.
presentation. And
Thank you.
as always, I'll save this recording. I'll give a link to it, and I'll give a link to your presentation and your information to your website and so forth for you there.
Thank you.
All right. Unless somebody else has got something there, we're going to close the books on this. Oh,
So what's for the new Globetrotter? Yeah, it's second, third week. I expect to have it ready. So now I'm gathering parts. And normally, I don't get SMD production done before Christmas now because it's so busy and they are still catching up of the first Corona wave because their production machines were confiscated by the government to produce ventilators. So it's very, very busy, but they promised me to help me in the first week of January. So.
this pandemic
Okay.
has affected all of us in one way or another.
Yeah.
All right. With
Okay,
that,
now then
sure.
I'm going to take a nap. I want to thank everyone for watching and listening. And yeah, maybe in a while with updates or new things.
Okay, look forward to that. Thank you very much, Gus.
Thank you, everyone. Goodbye.
73.
Yep, bye-bye.
73s, everyone.